All right, folks. We can get started in just a second here. We're going to be talking about basic operators. Just kind of waiting for my computer to settle in a little bit here. All right, let's have a little sanity. Okay, looks like it's running well enough. Good. So let's do a little recap, talk about what we went over last time. And I know I kind of spent a lot of time on the recap the time before, but I just wanted to make sure that really the stuff about data types was going to land well. And type, and the types that we would think of for representing numeric data, just regular base 10 numbers. Integers obviously have whole number values, and floating points can have fractional, or what we might think of as, oops, I'll let this load. Technically are a numeric type, although they only have two possible states, which are true and false. So rather than integers, which have all the various states of of numbers, a state being like it has the value of 1, or it has the value of 39, or it has the value of 7 billion and 4. So I don't know. But Booleans only have two possible states, which are true and false. And we spent some time kind of playing around with different things that evaluate to Booleans, different expressions that will give us a Boolean value back. So let's look at some of those. Just want to touch on this part real quick. Okay, I'll just go on my text editor for this, sorry. So the Boolean, let's give a little example. We'll say A equals 4 and B equals 5. And we can say A is equal to B. And this is not true. A is not equal to B. That is true, right? But you can see these are, we're asking Python to give us a true or false value for these sort of operations. Equal to and not equal to are especially common Boolean operators. Another Boolean operator that's common across types is and A in the list 3, 4, 5 is true because A is 4 and 3, 4, 5 contains 4. We also talked about some Boolean logic keywords. Those were not and Booleans. So not A equals B, right, is going to be whether A or B is true or false. Not will just invert that, right? So A equals B is false, not A equals B is true. A greater than B and B is greater than 10 or whatever. Both of these are going to be false though. And we also have or. So an example would be here. Let me show the example for. The example would be like a, well, just the same as this actually, but we could do or instead. And since both of these expressions on the right and the left are false, then this whole expression will give back false. Okay. When you're using not, and, or, what I recommend You don't have to do this. Your code will be valid, but I recommend using parentheses on the operands that you in doubt. Whenever there's an order of operation thing that might happen implicitly, just use parentheses to control it explicitly. That's my philosophy. I think it makes your code clearer in general if you don't go totally, overboard and start doing this kind of thing, like that's probably too many parentheses, right? But, a light amount of parentheses to help you explicitly communicate your intended order of operations. Usually just makes things more consistent and makes things happen more, just consistently. So that's Booleans. And the only reason I want to touch on these specifically is because Booleans, understanding where Booleans are used and how, like, what expressions will evaluate as Booleans is pretty important to understanding how to control conditional logic. We have talked about if and elif and else, right? So if what, right? Well, whatever comes after the if is something that ought to be able to be understood as being true. Be an example. Well, whatever comes after the if is known as the condition. So we could say if A less than B, which is true, A is 4, B is 5, so we know 4 is less than 5. Then we can just have our code here. And it will execute if that condition is true. If it's false, you can say else. And then print other. Cool. Oops. We also talked today. A lot of places they're used. They're also useful for dealing with data from the outside world that comes in the form of text that should be regarded. You might want to do math with it, and that's how. And just if you want to deal with, for example, just language text, if you want to manipulate text or do like natural language processing, obviously you're going to be dealing with a lot of textual representations of things. So let's just have a quick example here. So we can declare a string using double tick quotes or single tick quotes. I do prefer to use double tick quotes myself. So I diverge with Pep8 on this particular thing, but on a project that has like a standard that's already established. But if you're writing your own code and the only time exception, not the rule, and I don't just mix and match them, carelessly. So, okay, so let's look at a string real quick. Print. This is obviously what I did for the sanity check at the very beginning. Manipulation with slicing, which has the square brackets after. We can get the index. We can get this first L here. I can ask for a substring, a range of numbers. So I could start at 2, and we could go to, let's say, 2, 3, 4. We'll go to 4. And now 4 is exclusive, so this will actually be 2 variable here. And I'll have a variable. Give that a second to run. Apologies, I just need 1 second, and I will be back in stream. I'm gonna just sit right here, but I need to break the stream for 1 second. All right, folks, sorry about that. Cool. Back to strings. Okay, so we talked about how to declare strings and just basic string manipulation stuff. So, and then we talked about the none type. Basically, the takeaway with the none type is that if you write a function and it doesn't return something, it will implicitly return none. Print is actually an ironic example of this, right? Print, if I print, let's see what happens if I print. Well, you know what's going to happen because I implied it. So print returns none. So we're going to see none printed out because print makes something visible on the console. It does not return a value. So when there are certain places where Python thinks something should have a value, and if it doesn't have a value and it needs to supply one there, it may assume the value of none. None is by definition the absence of another value. You can also start things as none. Oftentimes, like you're creating a dictionary and it has a lot of fields and you don't know exactly what data is going to end up in those fields, and you may not know even the types of data that you want to end up with in those fields. You can just start them with none as just a placeholder, and it's, you know, it supplies a value that is the explicit absence of another value. So cool. That's the none type. Let's go for basic operators. Okay. So perform mathematical calculations using basic operators. Hooray. Using Python to perform calculations and implement machine learning algorithms, you'll need to learn how to perform calculations in Python and take advantage of operators to perform calculations. This is cool because we're getting to the point where there's a lot of times like where I just need a calculator, and like my go-to calculator for anything is just Python now. Even on my phone, I installed a terminal emulator app. That's basically what I have. If I need a calculator on my phone, I open my terminal app, and you'll want to do, you know, use number manipulation and math and in your coding, but it's just a nice, and we're gonna look at that. All right, we'll just go for this. Actually, that's a good point. Describe the operations that we've learned so far. We've talked about using plus for concatenation with strings. We've talked about comparison operators with Booleans, equal to, not equal to, greater than, less than, greater than or equal, less than or equal. What else? Assignment, single equals, that's the assignment operator, that is an operator. We've seen that one. Yeah, that's probably the main ones. We've probably talked about a few others, but that's worth knowing about. So let's look at the arithmetic operators. Perform calculations on int and float data types. Understand how arithmetic operators function for different data types. Oof. Sorry, my dyslexia is getting the better of me today. Can be used on many data types. For now, learning to use these operators on int and float objects will be sufficient. I mean, I don't need to go through all that. So we're talking about arithmetic, so this is numbers. The numeric types that we have built into Python are integers and floats. So I'm just gonna refer to them as numbers, and we're just gonna kind of use them interchangeably. There are some cases where the rules are a little different for integers than they are for floats, and we'll see that in a second here. So what can we do with numbers? Well, we can, let's do A and B again. A equals 4, B equals 5. Why not? So we can say, we can add them. So we can say A plus B. We can subtract. We can say B minus A. Of course, we can say A minus B too. That'll give us a negative number. That's just fine. B. Okay. I am so sick of this. I have to disable that right now. Oh, where's the autocomplete? I always forget where this option is. I'm just like lazy about looking it up. Packages, perhaps? I actually kind of think it is. Do not. Okay. That's broken. Alright. Sorry for the distraction. I'm just going to have to deal with that setting being on for now. Oh, wow. Sorry, it's okay, so we can add, subtract, we can multiply, we can divide using the forward. You can I know some people that like have a hard time remembering which one is which. The forward slash leans in the direction, like it's falling over in the direction that you write in, right? So it's falling over forward. Yeah, forward slash. So forward slash is just regular division. So if I do, let's say if I do 10 over 3, this is where things start to get a little interesting. So I have the integer 10 over the integer 3. What's going to happen? What's going to happen? Okay. So we get 3.333333335, right? So that's not surprising. 10 over 3 can't be expressed as an integer, so it has to be expressed as a float. Because of this, because when you do single slash division, some numbers can be can only be expressed as floats. When you have let's say 10 over 2, which is going to be 5, it's still, we're going to get as 5.5, or excuse me, 5.0. So the reason we get a float, well, this one gets, even though it could be an integer, is that when you have a mathematical operation, or I mean any operation, any procedure, any function, like you want to be able to count on its return type always being predictable, right? In this case, you want it to be as simple as always being the same. So you always want to float back. If I wanted this to be an integer, for example, I can use double forward slash, right? And that'll give me the integer 5. And I can also do over 3, and that'll just give me 3. So this is called floor division. And the reason it's called that is it rounds down to the floor. That's what it's called, or that's how you think about it. Like, so if you would get a float back, it's just going to round that down. It's going to round it to the floor, which means down. And it's going to truncate, which means chop off the integers. What I find myself tending to do this more often, though, where and I think this is just my own kind of eccentricity kind of preference, more than anything, but if I just tend to just cast it as an int like this with the int built-in function, and I don't know, I like it this more, but either one works in this case. Cool. So that's addition, subtraction, multiplication, division. We're not quite done with division. If you notice, something like, let's see, let's say 11 over 3. So if I try to put 3 into 11, I can get 3, 6, 9, and then I have 2 left over, right? I have a remainder of 2. I can't put 3 in again, so 3 goes into 11 3 times with a remainder of 2, right? There's times when you want the remainder. So if I want the remainder of 11 over 3, I can use an operator known as modulo. And this is just the percent sign. But in this context, in programming, we don't call this percent. We don't call it percentage. It doesn't do anything relating to percent 11 over 3. Sometimes I'll try to read a modulo operation in that way, because that's what it's doing. If it helps, you can think about the percent sign as the remainder operator. It would be a more semantically accessible name is to call it the remainder operator, but you do have to know that it's not called the remainder operator. Its formal name is Modulo Operator, is the Modulo Operator, and often we'll just read it as mod. So the way we'll read this is 11 mod 3. And you just have to know that mod means, mod or modulo means the remainder of. Now I think this one is easy to overlook, because there's already addition, subtraction, and multiplication work exactly how you think they're gonna. I was like, that was easy. And now there's 3 operators for division. You know, there's single, double, slash, and now there's modulo, right? And I think it's easy to overlook modulo. It's surprisingly useful. You end up using modulo a lot. Come on. You end up using modulo a lot. So if I want to know if, let's say, I have two random numbers, and we'll call them, we'll just do A and B again, right? I have two random numbers. I don't know what their values are. Values could be anything. These are coming from some outside source. We're going to pretend like these are coming from some outside source. So A is 3, B is 24. And if I want to see if A is a divisor or I want to know like true or false, I want to write a line that basically says, gives me true or false, is A factor of B. Let me surround these with ticks since true or false. What I can do is if B over A has a remainder of 0, so 0, then this is, notice we're combining the equality operator, and this was one of the Boolean operators. And I'll just put that in parentheses so we're clear about how this order of operations is going to happen. So we'll say B, the remainder of B over A will evaluate, and it'll give us whatever it gives us. In this case, 3 is a factor of 24. And we're going to check if the remainder of that, which is going to be 0, is equal to 0. If it's equal to 0, well, I'm not going to write it out. If it's equal to 0, dealing with numbers and you want to see, if something is a factor of something else, you'll write a lot of lines that are like, if B over A, remainder 0, whatever your code here. And you can do something special. I feel like writing a function. I feel like writing is prime and showing this. Let's write a function that takes in a number and tells us whether that number is prime. So I'm going to call this is prime, and let's print some tests first. So we'll say is prime, and this will take in a number. Let's do 4, and it's going to return whether or not a number is prime, so that'll just be true or false. Oh, well, actually, this one will be false. Excuse me. We'll do 5 is going to be true. 6 is going to be false. 7 is going to be true. 8 is going to be false. 9 and 10 are going to be false. 11 is going to be true. Okay. Whew. Say 4, 5. Oh, don't do this. Do that. 6, 7, 8, 9. Nice and even. Okay, so I have some tests to test my function. And I always do like to do this where I write the general before I even define the function. And I encourage you to do this. It might seem like a counterintuitive pattern. It might seem like I'm just being disorganized. I assure you this is a very deliberate pattern to write the tests before the definition. If I run my code right now, it's going to throw an error, and that's fine. Right? Like, it's not like getting the error is gonna mean that I'm gonna be like, I don't know, that like my car is gonna light on fire or something. Like there's a little reason I do, even though I've written this function before many times. I stay in this habit because if you have something like a call to the function as you're writing and defining the function, you can run it as you're writing it, and that gives you feedback on what whatever you've written has done to the code and whether it's working or not. So It's a very helpful thing. And it also gives you the chance to reason about, given a certain set of inputs, what do you expect your output to be? So it sort of establishes, it's subtle, but it helps you establish what your end goal is. Whatever I do, I better end up with some, if I thought of, so now we'll define it, well, yeah, we'll just kind of, we'll work this out. So we'll say, how do we determine if something is prime? Well, if you divide every number up to that number, or if you divide that number by every number up to it, you can, if at any point you get something that, you know that other number is a factor of n, and if n has any other factors other than 1 and itself, then you know it's not prime, right? So the first thing to do is to just get a system in place that allows us to divide n by every other number below n, right? So we'll say for div, yeah, we'll call it divisor, range n. Okay. So let's look at, say, if now okay. Now I need to adjust this range a little bit, because if I have it like this, it's like saying start from 0, go to n. If you put anything on the bottom in a division context, including in a modulo context, because you'll get an error, you'll get a 0 division error, not a widely agreed upon or established fact. So Python takes the stance of like, hey, you can't do that at 1. So if n over 1 has a remainder of 0, well, of course it does, because, I mean, presuming that n is a whole number, which according to how we're writing this function, we're assuming that it is, it's going to be where divisor is 1, n over 1 is always 0. Like, no matter what n is, everything is divisible by 1. So we can't start at 1. Can we start at 2? Well, some things are divisible by 2 and some things aren't, right? Well, we range, like a lot of like sort of upper bound things in Python is excluded. It's called or exclusive. So but we actually don't want to include them. So we're not trying to write the ultimate super efficient function. We're just trying to get something working. So if n mod divisor equals 0, then return false. If we make it through this whole for loop without returning false, we can just return true, because what we did is like divide every number possible, and if we didn't find anything to prove there, which is, what about numbers, what if n is, let's just handle the edge case up here. So we'll say if n is okay. Yeah. Cool. So let's just run that, and the pattern that we're looking for is false, true, false, true, false, false, false. If my code ever wants to execute. So false, true, false, true, false, false, false. So that's modulo. So that's an example of where modulo, like modulo is the heart of this whole function. Like all the rest of this code is to get us to this line where we can do modulo. So it's a very useful operator to know. Cool. So let's go back and look at some other operators. So we talked about, do that. And then let's talk about if we want to raise something to the power, we can say like, let's say a squared is going to be a star star 2. And if you'll notice, like when you're exponentiating, you tend to omit the spaces. And I think that's kind of, you know, just due to the way it's written. If you do, like, you tend to see it when it's written on a paper as kind of one thing, where you have a and then you do a superscript of whatever your exponent is, right? So if I want to square something, I can raise it to the power of 2. If I want to cube something, to the 4th, to the 5th, to the 6th, to the 7th, whatever. Some of you will probably know this, but the root of something, the nth root, let's get the square root of 16. So we'll do 16 to the power of, and then I like to do parentheses, 1 over, like conventional written radicand. You do the little check mark with the line over top, that's called a radicand. If you, if you do that, if you do the radical over the, over 16, actually, let me see, I think I can, is it? Oh, I thought it was that. I thought it was that key code. I must settle this. Certain. Oh my God. The lag. I don't know why my computer is lagging like this. No. No. All that to just paste in. Normally we would write the 16 like under the radical, but in this case we do the 16 up front, and then the, excuse me, I called this the radical before. This is the index. We can get the nth, and we'll do in there, right? So if I wanted the 10th root, I would do this. If I wanted the like this, just to show you where you would put the index that you wanted. You don't have to break it out into a variable or anything. Let's just say we want to do the square root of 16. That'll just be 16 to the power of 1/2. So that's a useful one to know. Cool. All right. So that's your basic arithmetic operations. All wrapped up. I can't say I've ever actually encountered a time where this was meaningful, but it's worth knowing, I guess. Booleans, we can do math directly on Booleans, and true will be treated like 1, and false will be treated like 0. So true plus false is 1, true plus true would be 2. False over true is 0 over 1. 0 divided by true to the false is 1 to the 0th power, which is, I guess, 1. Yeah, let's do this. Let's run this and see what's going to happen. Okay. Cool. So what's the result? What's the value of result after the following can be 8? So true. Cool. What's the value of result after the following code? 20. Cool. Ah, well, see, that's a good. It accepted it, but if I wanted to be more correct, I should have put in 4.0 because that actually is. We talked about that. Let's just go straight for the challenge, huh? All right, -9 floor divided by 4. I don't know. I'm bad at division in my head. I'm not. I don't know. See, this is the nice thing. Programming does not happen outside of the context of having a computer around to help you, so whatever. That's fine. Three. Oh my gosh. It's floor division. I totally could have done that in my head. If I was floor division, will just round us down to the lowest bracketing integer, which will be 3 in this case. So, what? I missed one? I missed one of the challenges? What's going on here? I must have just zoomed right past it. Okay. Oh. 21 over is going to be modulo. We talked about modulo. Let's just scan this to see if there's anything that I missed. Oh yeah, this is using modulo on floats and negative numbers and negative floats, between, on either side of the operator, and whether it was float and integer or negative or positive or two negatives or whatever. That's possible, but this is just saying, like, we're not going to cover it. It gets hairy and complicated and weird, and I've got to say, I've never had a need to use modulo with anything other than integers, just positive integers, I think. So I don't know. Not to say that you won't. Not to say that there aren't scenarios out there where you might, but yeah, we're just going to be using positive integers with modulo. There are many cases for modulo operator. Da da da. Okay. What's the result of this expression? So 6 times 6 is 36. So 6 times 5 is 5 times with a remainder of 1. So the remainder is 1. Cool. All right. Gosh, excuse me. I was like, nope, it's not gonna happen, and then it snuck up on me all at once. Ah, okay. Oh wow. Sorry about that. I hope that wasn't too loud. I really thought that was gonna pass, and it really got me. All right. So what's the value of this expression? 31 mod 2. Let's just do 31 mod 2. I should probably be able to do this in my head. 31 mod 2. So 31 over 2 is... Oh, gosh, of course I can do... Jeez. Oh, my gosh. I don't know what's wrong with me. I must have not slept right or something. That's pitiful. All right. Always use Python. Can you guess what the value of this expression would be? 324 times 69 mod 2 mod 2. 69 mod 2 is going to be 1, since 69 is even, so 1 times 324 mod 2, 1 times 324 is going to be 324. 324 is an even number, so an even number mod 2 is going to be 0. I did it without using Python, yay. Okay. Sorry, give me a second to just blow my nose. No more sneezing for the rest of the sessions. So for those of you who were taught PEMDAS, that is the order of operations observed in Python. So PEMDAS, let's just, for those of you who need a refresher, that's going to be parentheses, P, exponent, E, M is multiplication, D is division, which I'll include. I think there's an order of operations to division. And then let's see, multiplication, D, addition, A is addition. I see a lot of people trying to like lay things out, like, let's see, like, would be an example, like 2 to the nth minus 1. 1? Or 2 to the nth minus 1? Or is it 2 to the nth minus 1? Excuse me, I'm just reading that real quick. So, I mean, this is going to be evaluated as 2 to the nth and then subtract 1 from whatever that operation is. So let's print this out. No, it's taking so long to run. We'll print them all out at the end. So, but I'll see people write this code and 2 to the, well, look, and I put spaces here. I said I wouldn't. 2 to the nth minus. Easy to like know you mean that and forget to like put it there, right? But there are two ways that this could be, that the intentions of this could be read, right? Like either this, like the second, where there are people who disagree with me about the parentheses in, so that it's explicit what you intended it to do, right? You know, so even though, let's see, even though lines 101 and 102 are the same logically, um, it's my opinion, it's my correct opinion that line 102 is better because it explicitly states the intended order of operations, right? If I read somebody's code that's like this, I'm going to assume, well, you know, hopefully this is what they meant, right? And if I read somebody's code that looks like this, like, it's not to say that you won't ever make a mistake and parenthesize the wrong thing, but if you do, you're going to get the wrong answer. You're going to get it more obviously, you know. So in this case, I can be pretty sure that this person is telling me, whoever wrote this code is telling me, like, I want to do this operation. And this is a pretty small with a lot of moving parts. Like, if it's controlled entirely by implied order of operations like this, that's going to be a kind of a beastly line to read, versus if it's nicely parenthesized and readable and like explicit for if you intended to do what's on 104, is preferable to a line like 101 where you're just supposed to know. So okay, order of operations. Oh, right, because I have like a ton of invalid code up here. That's right. That's why. We'll do that. Result after the following code executes. So 2 squared is 4 minus comes first. So yeah, okay, that's just going to be left to right. So 5 mod 3 is 2 over 2 is 1. 2 squared minus 1 is 3. Okay, cool. Whew. I'm a little surprised I could actually do that. But let's look at this. Let's rewrite this line. Cool. So let's look at this line. This isn't even quite so bad, but yes. Cool. 5 mod 3, and then that result is going to be subtracted from 2 squared. So to me, hopefully you can see this, but it's much easier to decode that by eye just quickly, right? So there's a sort of a pattern that you can hear on are called operands. So for example, exponentiation operator. Operand, operator, operand for every set of parentheses. And a set of parentheses is itself an operand to an operator. So let's look at this. 2 is an operand. Exponentiation is a minus sign. And so is this set of parentheses, right? And so those are the 2 operands of the subtraction, right? And I think there might be other ways to like lay this out, but yeah, that's fine. And then 5 mod 3, this is operand, is whatever that expresses is the operand to this division, and this other 2 is also another operand to the division operator. Logical operators. Oh, we covered these. I covered these when we talked about Booleans. We kind of jumped the gun on these, but I think we kind of actually established these fairly well. I didn't talk about the bitwise operators, and I don't really want to. We'll just read this. It's in the context of bitwise operators can be used in place of and, or, and not. However, their behavior will not always be what you expect. So these are not just. So for now, we recommend that you avoid the other bitwise operator that we don't explicitly cover is the exclusive or, which is the caret symbol. Consider that an or statement will evaluate to true when at least one operands is true. Kind of a lot of overlap with exclamation point equal, which is not equal. So exclusive or is not often used. Into it. For now, know that they exist. So what is the value of result after the following code executes? So true is greater than false. True can be coerced to being 1, false to 0. And again, just in general, aids readability. So true greater than false is true. 1 greater than 9 is false. And I have one that's false, the whole thing is going to evaluate. The first part before the and expression evaluates to false, not 5 greater than or equal to 5. So the expression 5 is greater than or equal to 5 is true because 5 and 5 are equal. The not right-hand operand is. If it's false, it's true. If it's true, it's false. Oh, I already did that button. Order of logical operations. Okay. Logical operators. Not and or. Okay, we're going to ignore these first 4 because we're not going to use. Again, same rule of thumb here. Just use parentheses to make it explicit and clear what you're doing. I think there's just no and not is going to get into it. So not 3. Oh, that here. Not 3 less than 5. Up and easy to deal with thing. But what it's actually going to do is it's going to negate the next term. It's immediate operand. This is the nice thing about parenthesizing, right? If I wanted to do that, the only way to invert the whole thing is to use parentheses, right? So there's certain things where you have to use parentheses anyway, so I'm kind of the mind of just like get ahead of the curve and just use them. We're going to get some output. We're looking for the last 3 outputs from this file. False, false, and false. Cool. Okay, let's just go with false then. And it's not to say that you can't like try to like figure this out in your head, but again, I just think the parentheses just make it much. Will be printed out to the console after the equals to true, which will be negated, so that will be false, and then not 5 greater than or equal to 5. So okay, excuse me. So that's this first term is going to be true, but it's going to be negated, so that's going to be false. So since both of these are already, since one is already false, I know that the whole system, this and, is going to give us back false. And I know that already because one of its arguments or one of its terms is already false. So the first one is false, the second one is false. This is so result 1 is false, result 2 is false. Result you can see in later units, the parentheses. In result 1 will evaluate true, which will be negated by the not, yielding false, da da da. Okay, I'm not gonna go through the whole thing. Cool. Use basic operators to build Python functions and calculate the results of common mathematical equations. Yeah. Well, okay, it's about 5:30 for me, and